In this video, I'm going to turn this old fridge into an atmospheric water generator, a machine that can produce clean water out of air. Stick around to see if it works, and if you're into post-zombie apocalypse survival tech, hit subscribe for more videos like this. This is a super cheap fridge. The brand is Bowman. It's got a little thermostat in it, a drip tray, and a freezer compartment. The freezer compartment is the only bit that actually gets cold. At the back there is a temperature sensor for the thermostat. Around the business end there's a compressor and some other gubbins down there, and then a little circuit diagram and spec. I'll do a close-up of that. So the first thing I want to do is remove this shelf. Now what I'm going to do is have a look at the humidity. We're reading 23 degrees Celsius and 52% relative humidity. The fridge is off. I'm going to turn the fridge on and I'll see how those readings change. It's the sound of the compressor working. Yeah, that's getting cold already. 15 minutes is gone. Let's have a look how things have changed. Interesting. Okay. It's now 17 degrees C and 38% humidity. An interlude to explain the basics and why I was confused at this point. When we say humidity, we usually mean relative humidity, which means the amount of water vapour in the air relative to the total capacity the air can hold. So 50% humidity means the air is holding 50% of the water vapour it's capable of holding. 30% means it's at 30% capacity. Warm air can hold more water vapour than cold air. So when it gets colder at night, the capacity of the air goes down and the relative humidity goes up. 100% humidity is called the saturation point, where water droplets form. That's why in the morning the grass is all covered in dewdrops. So, going back to the fridge, I was confused because we started off at 50% humidity. Then as the fridge cooled, I assumed the humidity would go up, just like it does when a hot day turns into a cold night, but it actually went down. So what's happening here? Well, maybe someone can tell me in the comments, but my theory is that the fridge has a fixed amount of air and therefore a fixed amount of water vapour in that air, and the water vapour is condensing into water droplets and then freezing on the freezer shelf, which means that the air in the fridge is left with less and less water vapour, so the humidity goes down. So it also follows that if we want to pull a useful amount of water out of the air, we're going to need an exchange of fresh air coming into the fridge. Anyway, back to the build. This has been off for a few minutes now, and here's something interesting. The top of this is covered in water droplets. Okay, so here's my plan. I'm going to take these screws at the front out and I'm going to angle this whole freezer shelf down. The thinking here is just that with the shelf angled, any drips that collect can actually just drip off into a kind of collection bag. Okay. Now I'm adding a pump so we can have some fresh air exchange, so we can constantly have air blowing across the surface. So, let's turn it on. Alright, so it's only been 15 minutes, but I feel like this isn't going to work as it is at the moment. This, even though it's on 1 on the thermostat, the water is just freezing on here. It is getting water vapour on it, and I'm guessing you're not going to be able to see this very well, but there's like ice forming, and I don't really want ice, I want water vapour. So I'll tell you what, let's turn the fridge off We'll leave the air pumping and we'll see if a few drops might collect. Okay, well, this is just a few minutes later, and there's actually some water gathered in there. So that is kind of cool. Okay, so I'm kind of getting somewhere with it now. What I'm going to try next is to make a better collection system for the water using a plastic bottle and a plastic bag. I'm going to wrap the freezer compartment in the plastic bag, and then I'm just going to use a simple timer to turn the fridge on and off. So hopefully it will go through phases of a freezing cycle and then a defrosting cycle. Okay, this timer has these little nodules. Each one of these is half an hour, so I'm going to have it on for half an hour, off for half an hour, on for half an hour, off for half an hour. So we're going in. So I left this running for several hours and it produced very disappointing results. Just a few drops of water into the bottle. I'm not really sure what to change. I don't really know. I could try some different combinations, but it all seems a little bit clumsy. So I'm going to get a bit more technical and add some sensors and take some measurements. Then hopefully I'll be able to figure out what needs changing and get better results. So to take measurements, I'm going to use a cheap microcontroller with some sensors attached to it, which sends all its readings to a piece of software called Home Assistant, where we can see graphs and set up automations. This is an ESP32 microcontroller. I'm putting it on a breadboard to make connecting the different sensors easy. To measure the surface temperature of the freezer compartment, I'm going to use a DS18B20 digital probe. And to measure the air temperature and humidity, I'm going to use a BME 280 sensor. I'm also connecting a relay so I can switch the air supply on and off. And I'm going to use this smart plug to be able to turn the fridge on and off. A nice bonus is that this can also monitor the power. So if this experiment works, we'll be able to see how much electricity it uses. So I'm going to connect all the sensors together on the breadboard. Then I'm going to write a configuration file to tell it what's attached to what pins. And I'm going to flash that to the ESP32 to set it up. Once I've got that working, Home Assistant will show a new device discovered, and then all the sensor readings are available inside Home Assistant. So I'm taking the door off the fridge for easier access and removing the water collection bag so we can put the sensors in the freezer compartment. Then I'm adding the sensors to the freezer compartment with good old gaffer tape. I turned the fridge on and collected measurements for 15 minutes. Then I decided to put the door back on the fridge and collect measurements for another 15 minutes. This is the result. As you can see in this first part, the surface temperature drops right down below freezing, and the air temperature drops down a bit with it, and the humidity goes up a bit. Then this second bit is with the door closed. As the surface temperature drops, the air temperature drops with it, which is to be expected. But it's also showing that behaviour we saw before, where the humidity actually goes down rather than up. So I think this confirms that we don't want the door on the fridge for what we're trying to do, so I'm going to take that back off. And we definitely need fresh air going into the fridge. So I decided to get rid of the air pump as well and use a 12-volt fan to blow air into the unit. I've got a speed control on the fan that I made in a previous video. And I hooked the fan up to the relay controlled by the ESP so we can automate the fan coming on and off. And I set up a little control panel in Home Assistant that I can access on my phone. So I can switch on the fan relay. We've got control of the fan speed. Switch off the fan relay. And I can switch on the fridge. Then I set up some automations in Home Assistant, which is basically setting up simple if this then that kind of situations. I tweaked these a fair bit while looking at the graphs and looking at what the fridge was doing. I'm not going to document that whole process here because it was a bunch of trial and error. But after a bit, this is what happened. We've got drips. You can't see it very well, but there's quite a few drips coming off the middle of the shelf, which is amazing. Next I decided to move the fan over to the side so it can blow diagonally and get more surface area of the freezer compartment. Then I refit the water collection bag, and I decided to get rid of the air temperature and humidity sensor altogether to simplify things a bit. I also decided to move the temperature sensor under the freezer shelf so it's out of the way of the warm air blowing out of the fan. I think that was messing with the readings a bit. So now I'm ready to go and try and collect some actual water. Okay, so I've been tweaking this a bit and I've got some settings that seem to work quite well. I've got two different automations set up in Home Assistant, a freeze cycle and then a defrost cycle. So I'll show you what they do. The first one says when the surface temperature is above 5 degrees for 30 seconds, it turns on the fridge power and it turns off the fan. So it's basically just turn the fridge on, start getting cold. And then the defrost cycle, once it goes below freezing point for 2 minutes, then we'll turn on the fan and then we'll wait 5 minutes. The reason for that is during that time the freezer compartment is really cold and we want to just blow lots of air onto it to make more and more ice. Then we'll turn off the fridge power so that all that ice can melt and drip down into the bag. So I'll show you what that looks like in the graphs. This top graph is the surface temperature, and then this shows when the fridge turns on and off and when the fan turns on and off. So let's look at it in action. Okay, so the freezing cycle has just started, which means the fridge is on and the fan's not on. We've just hit 0, we've just hit freezing point. Fan's just kicked in. And I think this part of the cycle is quite important because this is where ice gathers on the surface. We're probably quite close to the fridge turning off and going into the defrost cycle. It's making quite a lot of ice. I don't know how well you can see that at all, but it's interesting. There's hardly any over there, but where the fan's hitting it, there's loads. Okay, the fridge is just turned off. So we're in the defrost cycle now, and this seems to happen really quite quickly. Surprisingly quickly, like. But see the drips coming off? Drips coming off the shelf. It doesn't look like much, but over a few hours I managed to collect a reasonable amount of water. If I left it running for a full day, I'm sure it could easily produce the 500 ml of water needed to keep a human alive. I suspect with further tweaking it could be a lot more efficient. I'd love to hear any comments on how I might further improve it. But is it safe to drink? Well, in theory it's producing very pure water, but of course there are all sorts of vectors for contamination here, and you'd probably want to filter it and treat it with UV light to sterilise it if you wanted it as a source of drinking water. But there's only one way to find out, so let's give this a go. Alright, here goes.